Hello everyone, I am Trupti Shah from Vidyavardhini's College of Engineering and Technology. In part 1, I explain you how to write a Verilog code for half adder and observe waveform in Xilinx software. Now today I will explain in part 2 how to create a bit file, upload a code on Xilinx board, FPGA board of Spartan V2. So for that this is the board, and we know that on board you can see here different ports are available. For example, deep switches, total 8 deep switches are there. You can use these deep switches to verify the different circuits, logic circuit. These are the onboard LEDs available. Total 8 LEDs are there. 6 push button switches are available. Then audio jack is there. Even provision for micro SD card is available. Here it is given 7 segment 3 7 segment displays are there. GPIO header is there, jack header is there. Even if 4 GPIO pins, 32 GPIO pins are there, that is 4 ports are available where you can connect externally input output devices. And one VGA connector is there for audio video configuration. Then power LED is available. You can connect 5V power supply from here. So these are different pins available and provision given for the development board. And when you start with the code to upload the board, for that we need two important things. When you go down here, we can see the configuration tool. Means in configuration tool, when you download it, it will provide you the software to upload bit file to the board. And software which we are using is the Elbertv2. I have already done in my case, so I will not show it, but you need to download it. And then user constraint file will required, which will show how the board is connected to different input output ports. So this is the user content. I have already downloaded Elbertv2 and USB file. We can see I have created one folder on E drive, Verilog programming. There Elbertv2 configuration is there, and text file my UCF is generated. Here you can see different LEDs, deep switches, 8 LEDs, which port it is connected to the board, deep switches, which ports are it is used, and different switches, whatever GPIO pins, external ports available, everything is given in UCF. As per your requirement, you can select anything and do the program. I'll explain everything in detail when we start with. So again, open the Xilinx software. Last part I have explained how to execute the Verilog code for half adder. So continue with that. And then I already explained how to create a half adder module and test bench. Once that part is done, you need to create a UCF file. So here I'll first show you what name I have given. Inputs I have given name A and B, and for output sum and carry. So next step is to go to project and create a new source for user constraint file. So here you select implementation constraint file and give the name, say half adder underscore UCF, and then next, finished. Here blank file will be created. Now see, on board I will be using 2 switches for input and 2 LEDs from board. So DP switches I will use. Go down and here you can search for the switches. So LEDs for output and DP switches for input. So first I will select 2 LEDs, one for sum and one for carry. So these 2 lines we can select, copy it and paste to the UCF. Then second, you can Then next to again go to UCF file, and two inputs, we need two switches from the board. So first two lines of DP switches we'll select and paste it in the UCF file. Give the name. LED we have given name as sum, same name should be given, and here we give carry, and inputs A and B, input A and second input B. So once this is done, save it and come to implementation part. After synthesis, this is more time consuming depending on the speed. So you have to first implement design, and then once a design is implemented, you have to click on generate programming files, which will create a bit file. So it is more time consuming, we need to wait for that. It is implementing the design. So we need to wait for that. So we can see the implementation is done, and then generate programming. Once you have done the generate programming file, it will create a bit file. Again, it will take some time to generate programming. The programming file is generated. Then here we need to upload a bit file to the board. So first for that we need to share one folder. So I'll explain you how to share a folder. For this, minimize this, and then in my case folder is already shared, but I need to explain you how to share a folder. Here I'll show first you create a folder. Say one folder is created in E drive. Create a new folder. FPGA. So I have created it FPGA folder, and how to share it, for that we need to go to, we have to open the virtual box, Oracle virtual box. Here go to setting, shared folder, add the folder. These already folders, some folders are added. Path you need to give, I have created in E drive FPGA board, so we can check it. First you need to select E drive, this PC, and E drive, where FPGA, select folder, okay, auto mount, and OK. Once it is done, don't forget to reset your device. Reset it. It will reset the virtual machine. Again, will take some time. Once it is resetted,